everybody, I hope you're doing well and welcome to the platform of CodeChef. So today we'll be solving the problem friend or girlfriend. The difficulty level for this problem is simple and there are no prerequisites required whatsoever to solve this particular problem. So there's your educator Ansh and I hope you like my video. So let's move on to the problem statement. Now let me just summarize the entire problem statement for you all. So basically in this problem statement, we have a n length string and we are given an alphabet. So let's denote my alphabet by small s. And then we have to find the number of substrings which contain this particular alphabet. So now what do I mean by that? So firstly, let's understand what exactly a substring is. So consider my any generalized string, say I take my string ABC. So the substring for this particular string is nothing but my A, my B, my C, my AB, my BC, and my ABC. So any contiguous group of elements that are occurring together can be counted as my substring. So my A, B, C, AB, BC, and ABC. So this becomes my substring. As you can see, for one length, I have my three. For two lengths, for one length substrings, I have my three substrings such as one length. For my two length substring, I have my two. And for my three length substring, I had my one. So for my length of three, I have my number of substrings as nothing but 1 plus 2 plus 3, which is nothing but n into n plus 1 by 2, right? So for any string of length n, there are n into n plus 1 by 2 substrings that can be generated. So now, but in this question, we are also given an alphabet S and we are told to find only the substring that at least contains this particular alphabet S and we are told to return the count for that particular string. So this is what the question is asking. Now let me move on to the approach to how do we solve such kind of problems. Okay, so now to form the approach for a particular question, let us take our example test cases. So here we have my string as ABB and my alphabet as B. So firstly, let's count the number of substrings that only contain the alphabet B. So here let me point out them. So here we have AB. So one string is AB, then we have ABB, then we have a string B, then we have a string BB, and then we have a string B here as well. So as you can see, the values of this particular string and this particular string is also the same, but since the strings came from different position, as this B came from the second position and this B came from the third position, these substrings will be counted as different substrings and hence the answer is 5 for this particular test case. Okay, so now let's form a bridge for this question. So let me show you this one basic observation that instead of counting B, first let's count those substrings that do not contain my alphabet B. So what we can do is we know that total substrings for any particular n is nothing but n into n plus 1 by 2. And then what if I do is I can just calculate my substring that definitely do not contain B, that definitely not contain B, and then I can subtract it from the total value to get my substrings that contain B. So because the substrings that contains B at least once, right? So this is required in the question. So if I take my total configuration, which is n into n plus 1 by 2, and subtract those particular substrings that definitely do not contain B, I'll get my substrings that contain B at least once, and that is my required case, right? So consider this only test case. So there's only one substring that do not contain B, and that is just A itself. My total substrings are 3 into 3 plus 1 by 2, which is nothing but 6, minus one substring that do not contain B, and that turns out to be 5, which is same as the answer that we calculated. Similarly, for this particular test case, let's see what our answer is. As you know, my AB string, and let me just group this particular string into two sections. So I know out of this all AB which do not contain any character of C, I know that 2 into 2 plus 1 by 2 substrings can be formed by just using this particular AB together. And similarly for this AB here which are grouped, I can again conclude that I'll require 2 into 2 plus 1 by 2, which is nothing but 3 for this and 3 for this. So total 6 substrings that definitely do not contain C. So now what is the total substrings possible? It was nothing but 6 into 6 plus 1 by 2, which was 3 into 7, which was 21, and then 21 minus 6, which equals to 15, And that is the required answer for this particular test case. And hence, this becomes our approach for this particular problem. Now let's see how we can code this approach. Okay, now let's try to understand the code for this particular problem. So firstly, we included all our header files required. Then we included my t-test cases. For t-test cases, I took input according to the input format as my n string and the integer k, or the alphabet k. Then I put my vector indices as initially as the -1 value. So basically what the idea is, I'm gonna select the value of the alphabet or the occurrence of alphabet and its positions. And what I'm gonna do is for those positions, obviously, if my one occurrence of alphabet is at position 2 and one occurrence of alphabet is say position 5, then obviously my alphabet between 5 and 2, there's no occurrence of those alphabets. Right? So what I'm gonna do is for all the occurrences of alphabet, I'll keep on traversing through the adjacent occurrences and then I'll subtract those particular occurrences to get the group of values which are surely free of alphabet K, right? So that is the idea. Like you append all the positions of that alphabet K, and then for every two adjacent positions, you keep on subtracting them to get the group of values of element between them, and then that becomes your free. Then that becomes the length of your substring that is free of alphabet K. And as we discussed in the approach, we have to calculate the total substrings, and then for all those particular substrings, we just have to calculate the number of substrings that can be formed for that given set of strings, and then we just subtract it from our total, giving us the final answer. So let me run our particular code through custom test cases to see whether everything is working correctly or not. So as you can see, we got the required answer. Let us submit our particular code to check whether everything is working correctly or not. So as you can see, we got the correct answer for this following test cases, and hence this becomes a valid solution for the following problem. Let me also show you the Python implementation. So in the Python implementation, we did the same thing. We inputted according to the input format. For each value of string equal to the alphabet, we appended its particular position, and then we appended the position of 0 and n plus 1 in the end. And then we simply traverse to every adjacent string, every adjacent positions, and I know the value of string in between will definitely be free of this character. So I can count all the substrings that do not contain that particular character and subtract it from my total substrings to get the answer. So yeah, this becomes the solution for this problem. I hope you like my video. Please like, share and subscribe to our channel. Thank you.